Hello everybody. I'd like to drop a quick video out there about T-TRAK-Z and about the feeders and bus options for the format. At the current time this video is taken, the standards do outline these type of connections, colors, etc. But I wanted to outline my thought behind using these, why we do them, and show the materials, tools, parts you'll need to be successful in making bus and feeders for this layout. I do have some experience with running these layouts in a large fashion. Did it in scale for a couple years, and then when I jumped down to Z scale, I took some of that experience with me and put these guidelines together for Z-Scale. N and Z-Scale T-Track are very similar in that there's a sectional track system, and that track system does include feeders. It includes a power system for connecting track to power and whatnot, but that system is a little weak in N-Scale, and it's very weak in Z-Scale. Rokuhan is missing some key features. For example, they do not include a three-way splitter. Some of the cable lengths are short. You can end up spending a ton of money and time, and the connectors are proprietary. They're hard to find. John Duino was able to find some connectors and is making some connectors and pieces of the system, especially for accessory, but this is more focused on, it's focused on accessory and power, but it's really more critical for the power distribution for a larger modular layout. So at the time this video is taken, this is a year in for T-TRAK-Z, and there are no large layouts. The largest layout that's being taken to a show is mine. I can set up in a 15 by 15 area roughly. So the layouts are not large enough to need things like power blocks or things of that nature. But this bus system will handle that amount of expansion. In N-Scale, they ran at Kansas City a year ago, they ran over 300 modules. Now that included power blocks and DCC slave boosters, but the cabling was very similar, used the same connectors, a lot of the same guidelines. So this should carry the format through for its bus and feeder needs. Okay, so I've rambled enough about the background here. So I want to show what we've got the modules set up for. So let's see. So the first question, I'm working off a small script, piece of paper here, but this is a one-take, no-edit video, so bear with me. So the first question that people are going to ask is, I'm only building a little loop. What is all this mess? You shouldn't really need all that. And that's absolutely true. So if you started with a Rokuhan R062 or other form of small double loop, and you've made a little small modular layout, a little something that fits on your table at home, you're right, you don't need all of this. You probably have a couple of track drops that Rokuhan provided with their power packs, and you're using that, and that's okay. So if you want to start out with that, that's totally fine. Drop the power feeders through the bottom of your module and run that way at home. When you get to a situation where you need to bring modules into a club layout or a show layout and combine your modules together, then at that point you need a common bus system that can expand and grow, and you have the same connectors as everybody, right? You don't want to bring your module in and have connectors that don't work with everybody. So that's fine for smaller layouts. When you go to a layout of any decent size and you want to play with other players in T-TRAK-Z, you need to build the modules this way. So I'm showing connectors on the back of the module. These can also be free hanging below the module. It's your choice. We use these in N-Scale a lot. They make the wiring really tidy. So the wiring is tight inside the module, and Anderson makes these outlets that snap into the back of the modules. All module retailers include these holes. So let me back up for a second. I got ahead of myself. So the system we're going to use is Anderson Power Pole. And you can see over here in the back I have a box with various connectors and various pieces to make this system work. This may look onerous to some people, but it's not that bad. It is this is very, very popular with people that need to do low voltage distribution. Ham radio is a good example. Ham radio operators use this system heavily. N-TRAK, modular floor standing N-scale, uses power poles. And T-TRAK N-scale uses a lot of power pole. There are some other types of connectors that people use in N-scale. The N-scale bus layout, bus specs are a little flexible. So people use different types of buses, but this is very popular in N-scale. So what is this? This is a system of housings and crimp connectors. I'll show you one of the crimps. This is the crimp connector, and this is the housing goes over it. And the idea is you crimp this on the end of your wire, and this crimp, just raw crimp, metal crimp, snaps inside of a housing. So the housing insulates the metal part, and it makes a snap connection. So you can take your connectors, and you can snap them together. The housings are keyed in a way that you can put housings in groups together. You can see I have a white and a black here. So this is accessory cable. I'll get into it in a second. But the idea is you build all of your bus, and for Z-scale we're doing module connectors in this connector style. All right, so we'll go back to the module here. So the module has two tracks on it. So T-TRAK-Z is a two-track system, right? So each of the tracks has its power, or has its feeder made available to the bus. So red and black on the outside, yellow and black on the inside. So a lot of people call these red and yellow tracks. I kind of hate calling it that, but that's what this is. These are both tracks are made available on the back of the module. And there is also a separate outlet here, or again, it can be hanging below the module for accessory power, 12 volt accessory power. I'm a big fan of lighting and additional fun things on the modules. This is a great example, right? Because this is, let me see if I can move here. So this is a shorty yard. So there is a separate controller that controls the back loop where the yard is. So I can do, you know, staging and everything for the shorties. And I can also connect the yard to the inside track, and I can run a loop where shorties run. So that power pack is ran on accessory power. So I bring 12 volt to the back of the module through a standard bus. Now 12 pack provides power for the power pack. So it provides track power. All right, so this is what it'll look like on the back of the module, or either hanging down from the module. So you've got your two track circuits, and you've got accessory power. You'll notice that the accessory power is positive, negative across, and the track power is positive, negative, or polarities up and down. So you can't mistakenly plug into accessory power into track power or vice versa. All right, so that's what the module connector looks like. You look in the standards, talk about how to do the module connector. This is it. This is what it looks like. And then again, there Anderson Power Pole makes this nice little snap-in outlet that you can put into the back, and it holds these connectors for you. Or you can just have them free hanging like this underneath the module if that's what you like to do. Let's see here. So bus cables. And I'm going to get into actually what I recommend for the bus itself. Again, people can build the bus however they like, but this is the bus system I build to go with the modules. The only thing T-TRAK-Z needs is this module connector, and then you, the club, your area, can decide how you want to build and construct your bus to work with these connectors. Now, this could just be a mating set of connectors and two Rokuhan power supplies. It could be that simple. I actually have, let me see if I can get over here. So I actually have a complete power system over here, so it can run DCC or be switched to run DC with the Roku power packs. And there are Anderson power poles behind this module that feed bus. I have two connectors, one that can go in each direction. So I have it built like this. Overkill for a small layout, absolutely. The only thing you need are the two Roku power packs that are there. You could just put Anderson power pole connectors on them. All right, so how do I recommend the bus be created? So I recommend using 12 gauge wiring, 100% copper. That's the material and size. Now I know people are going to say, my God, that's overkill, 12 gauge wiring for Z-Scale. Why would you do that? The reason is not for amperage, it's not for the amount of power delivery. The reason you run 12 gauge heavy cabling is that this cable will extend your reach much further without dropping voltages. Remember, Z-Scale is pretty low voltage to start with, less than 10 volts maximum. So if you have voltage drop across your cable, you're not going to be able to go very far. If you have 100% copper, full copper, thick gauge cable, the voltage drop is much, much less. So you can look this up and do the research on this yourself, but yes, thick gauge, 12 gauge cable, 100% copper. All right, so that's the bus material. For the feeder material, it's more flexible. You need something smaller, obviously. I use this, I believe this is 20 or 22 gauge. I'd still try to stick with solid copper, but it's not as important, right? Because these are short in length. These are only a couple of feet in length, maximum, right? So you need this for the bus, and you need a supply of this for feeders. I'm going to show you what the way I build and organize my buses. So this is a selection of bus cables. I run on my layout when I take it to shows, I run 2 circuits. Now on a more diverse layout where you have a lot of inner loops, a lot of loops in your layouts, then you may need more circuits, more colors, and there are more colors available. So Anderson makes a whole array of different color housings. I just build red and yellow. I only take coloration for 2 tracks. In a pinch, I could use these for a 3rd or 4th circuit, right? So this is 5-foot length bus cables with connectors. You can see these are actually have connectors that connect them. They're 5 foot in length, and I carry 4 of each of these lengths for each of these colors. So I have red and yellow, and then I have white for 12-volt accessory. So those are the bus cables, and putting them on reels or organizing them in some way. It's just like an extension cord, right? You got to organize your cables. So that's the bus cables. And to do bus feeders are going to be something like this. I do a pass-through feeder. So this is a small 6-inch section of bus cable, of thick cable, but it has small feeder wires added to one end. So you get to pull the power out of your bus travels behind the module, and you can pull out the feeder power out. So this is for accessories. There's 2 accessory connectors here. So the accessory bus travels behind or underneath the module, and then you get to pull the accessory power out. And this goes to the connector underneath the module or behind the module. For track feeding power, I have the same thing. I know this is a little messy looking, but it is a red and a yellow, and I bundle these together. So I have a 6-inch piece, and it's grabbing the red and yellow as it comes through on the bus. Same idea. It comes out in the small feeder cable, and it ends in this quad connector that your module needs. So this is the piece that you need regardless of how you do your bus style, is you need to have a feeder from your bus cable that feeds your 2 track circuits on the module. So that's a track feeder. So I have track feeders, accessory feeders, and I have bus sections. And the only other thing you need is a connection to your power unit. And again, this goes to my power unit behind me. Again, overkill for small stuff. You know, this could just be your Rokuhan cables from your 2 power packs that run into these modules. And then this could just be a wall wart. This guy, in fact, I have one over behind me for a temporary use. Just have a little wall adapter that goes into the white and black here for accessory. Let's see, what else do we need to talk about? I will show you the tools you need to do this real quick. Here's the deal. I don't expect a lot of people to be able to build these on their own. That's tough to do. I get that. What I am offering, and I do this for the N-Scale guys as well, to promote this type of bus style and to promote interchangeability with various clubs and individuals. I actually offer just a person-to-person, custom quote or for assembling these bus sections and feeder sections. I'll build whatever you need. It's something I do put a very small cost markup, and as you can see, I stock all of this material. So I want this type of bus to be common and interchangeable and successful. So I try to build it at just over my cost to get more of the same type of bus material out there, right? So I want to show you the tools to do it yourself, though. I'm a fan for self-sufficiency, right? You'll need the connector housings, and you will need the raw metal crimps for power poles. That's the key part of all the power poles. You'll need a housing and you'll need the crimps. These crimps are available in 3 different sizes. They have a small size that's great for the feeders that I've shown you. They have this medium size, which is good for the 12 gauge speaker cable that I'm using. And they also have a large size that is a open crimp that will take even larger wire. And I do use that in some cases as well. But this is the main thing that you'll need to make these type of connectors. The tool that you're going to need there is a crimper tool for power poles. So it's just what it looks like. You put the connector in with the wire inserted into the back of the connector, and then you squeeze this down. It's a ratcheting crimp. This will do the metal part of the power pole. And when you're done with that, you put the appropriate housing on top of, you put your metal crimped piece that you've already crimped, you insert it in here, and there's a click, there's a little piece of spring steel, it'll click into place. That's pretty much it. Other tools to make the work easier: wire stripper, automatic wire stripper, very handy. You'll need flush cutters, small flush cutters. If you're going to do a lot of bus cabling, a lot of, a large scale operation, you need cable cutters. Those are handy for cutting speaker wire. And lastly, you'll need some sort of small tool or pick. These sometimes do not, it's hard to insert these by hand because this wire is real flexible and you can't push it in hard enough. So you'll need a pick to insert and pop these into place. That's it for tools. That's all you need. I've rambled on long enough. This is a 20-minute long video already, so I'm going to cut this short. Again, I really don't expect that a lot of people will be interested in building this type of bus and whole system, right? So try to help out people and build some of this material. I think I charged $10 for a 5-foot section of cable, or I don't remember what it is. It's ridiculously cheap. Anyway, I buy this speaker cable in 500-foot rolls, and I buy the power pole parts come from Allied Electronics out of Texas. Don't mind telling people where I get this stuff. And they will send you bulk packs or small amounts, whatever you like. You need to know which parts to order. They're not very helpful on what each of the parts, what the part numbers are. So you'll need to look up the Anderson Power Pole catalog, get the parts number, and then order the parts. They're fairly reasonable, and Allied Texas has good, cheap shipping. They usually get to me in just a day or two after I do an order. But I try to stock all this material. If you're a pretty decent sized club, maybe a year or two down the road when you're watching this video, maybe you're part of a pretty good sized T-TRAK-Z club and you're interested in building your own bus material. 12 gauge all copper speaker wire. Be careful, do not get aluminum clad copper clad aluminum, CCA. Make sure it is not copper clad aluminum. It needs to be 100% copper. 12 gauge speaker wire, smaller gauge feeder wire. You're gonna need all your Anderson equipment, and you'll need a few of the tools. So we're just over 20 minutes. I'm gonna cut the video short. Hope you found it helpful. Thanks.